It's your friendly math tutor, Miss C, here to simplify exponential expressions using the power of a quotient property. Here's the big idea. The power is applied to each variable and each coefficient in the parentheses. So let's have a look at how this works. So in our first example, we have a 2 in the numerator, we have n to the power 4th in the denominator, and that entire fraction is raised to the power of 3. In math, that 2 really can be rewritten as 2 to the power of 1. And this is where this property is very similar. It's technically the power of a power property, because the way we approach this is we have 2 to the power of 1 all raised to the power of 3. That's a power on power, which means we multiply our exponents. So this becomes 2 to the power of 1 times 3, which is 3. In the denominator, we do the same thing. 4 times 3 is 12, so this is our simplified expression. That being said, I would want to see as a math teacher 2 to the 3rd expanded out because it's such a small number. That's 2 times 2 times 2, or 8, over n to the 12th. And that is our simplified expression. All right, our next example adds a little more complexity because we have a coefficient and a variable in the numerator. Remember, those both have a power of 1 on them, so let's go ahead and do this. We are multiplying 3 by all the exponents that we see. This becomes 4 to the power of 3, a to the power of 3, right? Because I multiplied 3 by those ones. And then in the denominator, we have b to the power of 5 to the power of 3, which means that we multiply the 5 and 3 together to get 15. Now, again, 4 to the 3 is a relatively small number, so I want to simplify that even farther. So this becomes 64a to the power of 3, or a cubed, divided by b to the 15th. And that is our simplified fraction. Let's take it up a notch. We have a negative exponent, so we're going to do the exact same things that we were doing. So we have 5 to the 8th. Even though it's negative, I still just multiply as expected. So negative 2 times 8 is negative 16, all divided by b to the power of 10 times 8, which is 80. Now, most instructions for math problems say that they want us to write our final answer with positive exponents. I have an entire video on that, but essentially what that means is we need to move this part of our expression to the denominator, and the reason we do that is a shift in location changes the sign on our exponent. So 5 to the 8th stays in the numerator, b to the 80th stays in the denominator, and I'm going to shift g down, and when I do that, the exponent becomes positive. Now, you could also write this so it's g to the 16th times b to the 80th in the denominator, and that would also be the correct because that's an equivalent form. I am not expanding 5 to the 8th out because 5 to the 8th is a really big number, and this is the cleanest version. All right, one last example that has multiple parts. I'm going to go ahead and go through this. You might want to pause this video and see if you can do this and check your answer at the end. But remember, we're going to write our final answer so that all of our exponents are positive. So I'm just multiplying every exponent by 8 because that's the power of a power property to get this simplified form. And once I do that, I notice that I still have a negative exponent right here that I need to shift to a positive exponent. So I'm just going to rewrite this. And remember, a location change in the fraction changes the exponent to a positive. Because I like little math humor, I spelled a word in this one. That a to the 32nd can be placed anywhere in this fraction, or anywhere in the numerator of this fraction and be correct, although we tend to write coefficients first. That's the most correct way to do it. 10 to the 8th, by the way, is a huge number. That's why I'm not expanding it. And there you have it, power of a quotient property. Make sure to subscribe for more math videos. Till next time, remember, you've got this.